as we begin day 2 of the transformations unit, we have to start getting the rules in our heads. So let's do a little chart at the top with all the transformation rules. So everything will be in terms of X and Y. Now what we do when we add, and this is one of the letters we use in geometry to show adding something, we add K. So I'm going to show this here. When we are moving right or left, we add K here and subtract K here. And this is when we change X. I'm having issues with my writing here. Change X. So right is X plus K. And left, moving left, would be minus K, all right? We talked about that last lesson. When you are translating left or right, you are changing your X coordinate because you're not moving right up or down. You're going left or right. So let me set these up and then we'll do it. I'll even do a different color. Now when we go up or down, you change Y. Sorry guys. Change Y. Up plus K, Y, down K. So this is Y plus K and Y minus K. Okay? Haha. Remember, when we are translating up and down, we're not moving left to right, so our X coordinate stays the same. We are simply shifting our point up or down a certain amount of units. All right, so we've got that one down. And I'm going to look at this one. On reflection, when we reflect across the X axis, we change the Y sign. Y, and I'm going to put change sign. That is an M. When we reflect across the Y axis, we change the sign of our X coordinate. Change sign. So you have to remember, again, we're folding the paper. If you fold across the y-axis, you're folding the paper vertically up and down. And so you're not changing the height of your dot, you're changing what side of the axis it is on. All right, now rotation. All right, I'm going to start with my original points. My original points are going to be X, comma, Y. That's the rotation. And we are looking at rotation clockwise. Clockwise. All right, got to memorize that. So keeping everything in terms of X and Y, 90-degree clockwise rotation becomes the right thing, not that. It's really hard to read. Becomes Y, comma, negative X. All we've done is we've switched things. We're keeping them in terms of X and Y. So you flip and change the sign. 180 degrees, you change both signs. And 270 degrees clockwise, negative Y, X. So here, 180 degrees, just change signs. Okay, this is flip and change. And this is flip and change. I know my writing's sloppy and I apologize. All right. Now, we're going to take this and we're going to apply it all. So first we're going to draw an A. We're going to draw it after a translation. 4 units to the left and 4 units up. Now, honestly and truly, the easiest way to do this is to label all 3 points in the original figure, do the math, and then plot them. So I'm going to mark them in black. It was so much easier this way. This is -2, 4. This one is -1, -4, and then we have 2, 0. Now we're going to go 4 units to the left and 4 units up. So, lots of colors on this one. -2 -4, comma, 4 +4, which, I'm going to do this in red, which becomes -6, 8. All right, I'm going to do this for each point because I find the math far simpler. I'm going to do lots of colors. So -1, and again, I'm going 4 units to the left, so I'm subtracting 4. And -4, I'm going 4 units up, so I'm adding 4 to the y. My very sloppy arrows, -5, 0. And my last point, I think you're seeing the pattern here. My last point is -2, 4. So now I'm going to plot them, okay? -6, 8 is up there. And -5, 0 is down there. And -2, 4 is here. And now I'm going to connect them. When you do it with the math for each coordinate point, it is extremely simple. You don't have to plot one point and then try to figure out where everything goes. Write down all 3 points, then do the math. All right, I'm going to do the same thing here. Second one in B, we're doing translation 1 unit to the left and 4 units up. So let's write my points. I'm going to mark them. And there's no particular order. I just happen to go left to right. -3, -2, -1, 3, and that's a sloppy parentheses, 2, 1. Let's do some transformations. -3, and I'm going 1 unit to the left, so I am subtracting 1. And I'm going 4 units up, so I am adding 4 to my y. And this becomes -4, 2. Now when you're doing this on your tests or in your work, I don't expect you to write everything down. I'm showing you how to do it, so while you are learning, you can write it all down to make it very clear for you. But as you go, you are not going to need to do this. Whoops, 3. My bad. +4. This becomes -2, 7. And here's something I've told you guys for quite a while. Do not try to make the numbers go where you think they're going to go. Simply do the math. Don't say, oh, this number looks weird, it can't be right. No, just do the math. The numbers will take you where you need to go. That becomes 1, 5. Well, let's see if I did my math right. -4, +2 is here. -2, 7 is here. And 1, 5. 1, 5 is here. -2, oops, that's a 3. Kind of helps if you plot it right. There we go. I knew something didn't look right. 1, 5. There we go. Okay? It's not hard if you write all 3 points. That's my best advice to you. Let's go to the next page. All right, now you are going to translate if it's possible. Now, this is where it's going to be kind of interesting. So you want to translate, which means to shift. Remember, translating is shifting. Translating is not rotate. You want to translate the solid figure exactly. Okay? Now we have to look at this. Is there any way we can take this, whoops, I always go left to right. I don't always pay attention to the words. Pay attention to the words. Solid figure onto the dash figure. Here's the solid figure. Is there any way to make all the points meet on this? Is there any shift we can do? No, not possible. These are different sizes. You cannot do it. So let's take a look at this one. Can we translate this figure to this figure? Well, they look about the same, don't they? So what happens if I go from here to here? Let's see. How many places is this? This is up 8. And from 4, 4, that's up 8. Oh yeah, I can. Yes. Up 8. So we don't want you just to say yes or no. We also want you to say how. And these are congruent figures. You learned that in Unit 5. These are not similar. These are similar. These are congruent. You can translate congruent figures. There's no way you can translate similar figures because similar figures will not ever completely match up. All right, now, keeping track of our rules, which you have on the first page. You're going to draw the reflection of the triangle across the x-axis. So, as I've been telling you, do it with math. Let's write our points. -8, -1. -3, -6. Then we have -2, -2. When we reflect across the y-axis, got to read carefully, doing great. Y-axis, we're going left to right. So what are we changing? We changing the x or the y? We are changing the x. All we are doing is changing the sign. This becomes 8, -1, 3, -6, and 2, -2. So let's plot it. 8, -1, 3, -6, and 2, -2. Connect my dots. We reflected it across the y-axis. Reflections are probably some of the easiest things you're going to get to do with this because you're only changing one coordinate. Now, I'm going to reflect this across the B goes across the x-axis. So I'm going this way. So do you remember which coordinate I'm changing? Think about it while we write the points. This is 2, 3, not 3, 2. Sorry, guys. Yeah, Mrs. Gates still makes mistakes. I am not perfect, and I am never going to pretend to be. 2, 3. And then we have 3, 6. And then we have 8, 2. Now, I'm reflecting across the x-axis, so do you remember I'm going to change the, wait for it, sign of the y coordinate, because we're not shifting left or right, we're going up or down. We're flipping up or down. So this becomes 2, -3, 3, -6, and 8, -2. Let's plot it. 2, -3, 3, -6, and 8, -2. Connect our dots. If you were to draw these in marker on very thin paper, and you folded the paper along the center line, the x-axis, that's what you get. So that was pretty easy. All right, next part. Now we're going to reflect the figure onto the dash figure if it is possible. Now remember, when we talk reflections, we are talking changing the signs of coordinates. There's no shifting, there's just changing the signs of coordinates. So let's look at this. Now reflections also means everything looks kind of the opposite. You can play around on your computer. If you put your photo booth on, I think you can set it up so you get a mirror line down the middle, and then you can see what reflections look like. All right, so let's look at this. Can you reflect this solid figure onto here? Well, reflect means I'm going to fold it over, and it also means I change the y coordinates. So let's just see. This coordinate here is -1, -6. If I reflect it across the y-axis, because that's where it is, I change the x coordinate, right? So a reflection, it would be 1, -6. Well, look at that. This point is not 1, -6, is it? Nope. That tells you right there it is not possible. You can do it by visual, and you can also do it by math right there. You know this coordinate point is not the reflection. All right, let's look at another one. Look at yellow. Reflect this solid figure. Let's check it. Well, let's look at some coordinate points. Remember, coordinate points are good. Let's take this point. This is 3, -7. If I reflect it, it should be 3, 7. This is 3, 7. Okay. And if you go through the rest of the points, you'll see, yes, you can reflect this. It reflects over the x-axis. Now look at A again. I want you to look at that figure. You can translate that polygon, that trapezoid, you can translate it, the solid one on the dotted line, because you can shift it, but that's not our question. Our question is about reflections. Make sure you understand your terminology. Translation means you are shifting something left and right, or up and down. Reflection means you are folding it over an axis. That's why A is not possible. It is not a reflection, as I underline reflect or highlight it. Okay? So that's the difference. Now, we're going to, again, use rules. We're going to work on rotations. You've done translations, shifting left and right. We've done reflections over x-axis and y-axis. Now we're going to do figures, and we're going to rotate the figures. And again, do it by labeling your points, by doing the math for your points, and then drawing it. So much easier. All right, I'm gonna make my points really obvious. So this is 1, 2. This one is 3, 4. And this one is 5, 1. Now for A, we're going to do a 90-degree clockwise rotation about the origin. We say about the origin because we want you to know that we're not throwing anything weird. It's just like this was a pinwheel. Do you know what a pinwheel is? Think about what that might be. It's something on a stick, and you put it in the wind, and it flips around in a whole bunch of rotations. That's what we're doing. We're putting this coordinate plane on a stick. We're putting a stick right through the origin, and we're just rotating the entire graph. All right, so a 90-degree rotation clockwise. What do we do with our points? A clockwise rotation says you flip your X and Y and you change the sign. So flip X and Y and change the sign. All right? Not so bad, not so bad. So you got 2, -1. Flip X and Y and change the sign. And you do that for all three. Once you figure out one, the rest are easy. Flip X and Y and change the sign for -3. Oops. One, -5. Okay, flip X and Y and change the sign. I'm gonna write this down. Flip X and Y, change new Y sign. I hope that makes sense to you. That's what I did. I flipped X and Y and I changed a new Y sign. Okay, I'm gonna plot it. 2, -1, 4, -3, and 1, -5. This has been rotated. Okay, that's a bad line. It's pretty bad when even in this thing I can't draw a line. Let's make this neater. Sorry, guys. There we go. Okay, we have rotated it. We have taken it and rotated about the origin. Now we're going to do the next one. Same concept with your points. Write them down. This would be 1, -6. And I've got 3, -2. And 5, -4. And this time we're rotating 90 degrees counterclockwise. So counterclockwise says you flip them and you change the sign of your new X. Because 90 degrees counterclockwise is just like 270 clockwise. So let's go to our notes. Let's go to the top of the page. Top of the notes, it says change sign. You go -Y, X. That's what it tells us to do. So let's do it over here. This becomes 6, 1. This becomes 2, 3. And this becomes 5. Whoops, not 5, 4. Fix that one. This becomes 4, 5. This one. Flip X and Y. Change new X sign. Plot my points. 6, 1, 2, 3, and 4, 5. Okay? There you go. Make sure you let me make this a little clearer. Make sure you write your points, because when you write your points, that's going to help you, all right? Well, it would help you if I did the right point. So, you know what I'm going to do? I'm looking at my drawing, and look what I did. I'll be honest, I screwed. This is 1, -5, not 1, -6. So let's correct that. That's an easy correction. It's a beauty thing about notes. This is -5, which means that this point is 5, 1. I didn't think that reflection looked right. rather the rotation looked right, and I was right. So this should be 5 comma 1. You know what? Sort of embarrassed I made a mistake, but then again, sort of not, because it's good for you to learn how to check. So now 5, 1. This looks much better. Okay, much better. There you go. As I'm checking all my other points just to make sure that was 5, 4. Yeah, okay. Make sure I didn't mess those up. All right, it gets a little tedious, but truly, truly, do your math. The math makes it simpler. All right, on this last part, what we're going to do is rotate the figure if it's possible. Okay, now this gets really interesting. A couple ways you can do it. I think I'm going to recommend that you look at your points. Let's find coordinating points, okay? Corresponding points. Remember we learned about that in triangles? Let's do corresponding points. Solid onto the dash. So I'm going to write all these points down. And so my points are 2, -4, 1, -6, and that would be 5, -4, and 4, -6. Now keep an eye on your new figure, and I'm just going to write down the coordinate points that correspond, all right? Let's see. Let's see if this is possible. All right, so this corner I think corresponds with this corner. So let's see, that would be 5, -4. This one is, yeah, I think that works. No, maybe not. I'm working it through my head, guys. This is 6, -1. I'm going to put matching numbers. This is 6, -4. I'm sorry, -6, -4, -6. And this one is -4, -2. And this one is -4, -5. Okay, so I've got all my points written down. I've got all my points. It was easier to do it that way. So let's take a look. Let's analyze what we got. So going from 2, -4, I flipped and switched the sign, didn't I? So flipped and changed new y. Did I do it here? Well, the -6, 1, -6, if you look, we did. We flipped the signs and we changed the sign of each new y. Each one was done the same, so this is, yes, this is a 90-degree clockwise rotation. Do you see how I did that with math? I wrote down my original coordinates. I matched with the new coordinates. I put the numbers that were the same. And then I found out that for each pair, we did the same thing. Each pair flipped x and y and changed the sign of the y. So we did it with our math. Okay, let's do this solid. Same concept. Let's see if it works. -6, -2, -6, -5, -5, -2, and -2, -5. Okay? And let's see what we do. I'm going to try to put coordinating points together, all right? Because I kind of like that. Draw my little arrows. All right, this point, -2, -5, goes with this one, which is 1, 5.5. All right, that's interesting. -1, 5.5. And then if you look at this one, okay, take a look at these. None of these match up. None of these are whole points, are there? That's not an intersection. That's not an intersection. They're all decimals. That's not intersection. So none of them really match up. So this is not possible. When I looked at my trapezoid, I found a point. Okay, now this point here, if this was a true rotation, and this point here should have some sort of system. They should have some way to translate it or to change it, excuse me, and there wasn't. This was 2, -5, and this one was nothing. It was -1, 5.5. So there was no way I could rotate this point to there. Could not be done. Nope. No, not possible. Nope, no, I think I've made it kind of obvious. The math takes you there. All right, guys, go ahead and practice this and it'll help.